All right, we are recording objective 11. I have my calculator, practice test A. I'd be appreciative if we could be quiet so that we don't have background noise on our recording. To determine a molecular formula, we have to work out an empirical formula first. The first problem you can see will be easy enough because the empirical formula is already provided. We're given an empirical formula, CH4N. What we'd like to know is the molecular formula. We said that this would become our target weight of 60 grams. So if we know the empirical formula and want to find its true molecular formula, step 1 says, let's add the empirical formula weight and see where we're at so far. So just on my calculator, I can add an empirical mass, carbon giving me a contribution of 12 gram units, 4 more for the hydrogen, and 14 for the nitrogen. We can see the empirical formula mass giving us 30 units so far. So step 1, we just simply added the empirical mass and found it to be 30. What we'd like to know is, how do I have to double it, triple it? What multiple of our empirical formula do we find from the target mass? So we said the easiest thing to do is take your target and put under the empirical molar mass and simplify that fraction. We can see 30 going into the target of 60 twice. And from there, we take this whole number and just simply distribute it through our subscripts to find our molecular formula. Twice as heavy becomes C2H8N2. A molecular formula who adds to 60 and yet reduces down to that 1:4:1 ratio. With our second question, we have to work out an empirical formula first, followed by seeing how many times it goes into the 120. So it's a little bit more challenging, only in the sense that I wasn't given the empirical. We go through the steps of determining it. So step 1, we're just simply going to rewrite our percent by mass of each element into terms of grams. In a compound, 40 grams will be coming from carbon, 6.6 grams will be coming from hydrogen, and 53.4 grams coming from oxygen. The percent by mass is simply converted into gram units. We know that subscripts stand for mole numbers, so we take each and divide it by its atomic weight. Even if it belongs to that lucky 7 horses need oats club, we still use atomic weight when we're changing it into a mole. Carbon uses 12, its atomic weight. Hydrogen uses 1, its gram atomic weight. And 16 for the oxygen. And then just one step at a time, we convert our gram units into moles. So when I hit 40 divided by the atomic weight of carbon, 12, we have 3.33 moles. Hydrogen remains at 6.6 moles. And hitting for oxygen, 53.4. Divide by 16, and we get 3.33 moles. We skim through our list to find the smallest number of all, which here is 3.33, turning our ratio into a 1:2:1 subscript ratio. So processing through for our empirical formula, we end up with a compound whose empirical formula, the lowest ratio possible, CH2O. We're not done yet because we're being asked to solve for a molecular formula. But now we pick up the problem just as if it were before. We're going to find our empirical formula weight and see how many times it goes into the target of 120. So let's begin by adding a carbon, 2 H's, and an oxygen. 12 plus 2 and 16 gives me that target of 30. Our target weight of 120 over 30 simplifies to a 4. So we have to make our empirical formula 4 times heavier. C4H8O4. A molecular formula who weighs 120 and simplifies to a 1:2:1 ratio. I'm going to pause the recording here and ask you to just work ahead for that next problem.